I'm Chris Hogue. And this happy young lady just graduated in July from the National University of Singapore with a PhD in computational biology. And I've spent the last 30 years doing computational biology in academic environments. And I actually wanted to be an astronaut when I was a young lad in the 60s, but that wasn't quite the path that I took. I studied biochemistry at the University of Windsor and got a PhD in biochemistry at the University of Ottawa, and then moved on to the home of the genome at NCBI and learned a lot about how to stand up early version 1 web servers and build three-dimensional visualization tools. And that led me to about a decade of career in Toronto. And later on, I started teaching undergraduates and graduates. And if you were in my class, I would start off lectures like this. You wouldn't have any computer science classes. You would get this all from the computational biologists who assumed that you knew all this stuff about biology. So in addition to having all this stuff in your head about cells and DNA and proteins, we expected you to learn an even greater set of information about software. And we do, in fact, build all types of software, including servers and daemons that hook up to instruments in Windows environments, in Unix environments. And we had to spend a lot of time getting students to get their heads around complex pieces of data, because biological structures that have three-dimensional coordinates and DNA sequences that have lots of abstractions, those all have to be understood in the framework of data structures. And we had hoped that they would also understand something about hardware performance, because the data was actually very large and has always been large since I started in the early 90s. It's always stressed the machines, and we tried to get students to understand just how the different parts work. Now, successful students also were impressed that they couldn't get by with one language. They had to learn a multitude of languages. And I had the pleasure of spending a lot of years learning these, but these happy students that were in my second last cohort managed to get through several of these languages and also made some nice Maya illustrations. Oh, and you can buy gum in Singapore. That's me buying gum in Singapore. So that's all a lie. This is my last class from late 2012 in computational biology, 4th year. I taught them in every single year, and most of them are employed now. Wonderful. So one of the things that I spotted sort of late in the game, probably around 2011, was looking at my curriculum. The performance of JavaScript was starting to widely outstrip the performance of the classical languages that we've used in bioinformatics, Python and Perl, and that was, of course, due to the browser wars and the pickup of the V8 JavaScript engine in Node.js. And I happened to notice this and told my students that they should probably look into this, because this was been coming. And I drilled down. I'm a pathological researcher. We actually implemented a tool in a very large website that we built that describes what's called mechanobiology. And that was a link-out tool built in Node.js and run through a Google gadget on the Google site system. And I thought that was pretty cool. And so I started playing with SmartOS and deployed it on 64-bit Atoms and then single-box Xeons and all the way up to a rather large 43-terabyte server, and was quite impressed with the benchmarks. I've been benchmarking protein Monte Carlo simulation code since 2002 with my own code, and so I know pretty well how systems work in both I/O and CPU operations, and this was quite nice. But more importantly, I've got an in-memory pipeline that runs in C, and the observability that is provided in Illumos and SmartOS through dtrace. You can see the flame graph here. This is the stack calls throughout that program. That was something that I had never seen before, and that was quite impressive. So I kind of fell in love with the technology and the joint stack, and now I'm actually Senior Director of Technical Marketing. So I went from being a professor to being a guy in marketing. It was quite a career change. I'm in charge of actually making customer demos and explaining complicated new systems like the Manta storage system. And I do that by trying to build demos. This is the case of the Getty public art collection, which intentionally has 7 blank pages from the 1400s in it. And that's me. I'm now a student of this premier collection of software engineers, and it's been a great ride, and I'm looking forward to my new career. Thank you.